Hello students, we will continue with the previous lecture. So we were talking about the kind of models that we have. We have talked about geometric models, we talked about probabilistic models, and the third category is the logical models. So in logical models, we use logical expressions to divide the entire instance space into segments. So just to reiterate, instance space is all the possible combinations of the attributes available with me for a particular model. So I use a logical expression to segregate this instance space into segments and then construct grouping models. A logical expression is an expression which returns a Boolean value, true or false. We already know that. So once the data is grouped according to these true or false values, the data is then divided into homogeneous grouping for problems that we are trying to solve. So there are two kinds of models that we have, or logical models. We have tree models and the rule models. Let's look at them one by one. So in the tree model, what we do is we use features to construct the trees. So suppose I have n number of features. I have x1, x2, xn, and I have a target variable here. Now I have these n features with me. Now out of these, I will choose one of these to be the root node. So suppose my root node is x2. There are various algorithms to find out the root node, and we will talk about that in the specific lecture for trees, decision trees. Now suppose I find out that x2 is my root node. So this will always be represented as an ellipse here. Leaves are rectangular. So my leaves ultimately, so they could be various levels here, and ultimately I'll have some decisions here. So they could be classes. So here if I have y as a class, so it could be maybe I have two classes, a 0 or a 1. Then it could be a class, it could be a real value if I am trying to find out through regression some value, then it could be a real value. It could also be probabilities. So I could be ending up with some probability of the occurrence of that particular instance. Leaves are rectangular. These are my leaves which are terminal, and they contain class, real values or probabilities. By using features present in the instance space, a feature tree is constructed. So I will use all these features and I will try and construct a tree here. If the value is class, if finally I have a class here, then this feature tree is known as a decision tree. And this is a typical divide and conquer approach which we have studied in our algorithm section also. So this is an example here. Suppose I am trying to find out, I have values of a person. So I have the savings that a person has, the assets a person has, his income, and I am trying to find out whether I should give him credit or not. So the credit could be a good risk where I am likely to get back my money, bad risk where I am not likely to get back my money, and out of these parameters I am trying to find out this. So this is a classification tree where I have these two classes here. So this is known as a decision tree. Now suppose from the algorithm that I use, I find out that the root node is going to be saving. So I start with this. It could have various values. So it has three values: low, medium, high. If it is low, I come here. If it is medium, I come here. So at medium, I immediately know it's a good credit risk. If my saving is low, then I check the low value of asset. If it is low, then I say it's a bad risk. If no, it's a good risk. Similarly, if my savings are high and my income is less than 30k, it is a bad risk, else it's a good risk. So this is how my decision trees look like. How we reach to this, how we derive this will be covered in the specific lecture of decision trees. But these are kind of logical models. Now after decision tree, we could also have a feature list. So we were talking about rule models here. In the rule models, we have implications of if-then rules. So here also we were saying if savings are low, then we check the assets. So from this decision tree, I could also construct a feature list. So we could say if saving is medium, then good credit risk. So credit risk is equal to good. So here they are checking for if savings is high, then I am checking my income. So if saving high, then check the income and then find out the credit, and else, so when it's not medium, it's not high, it's obviously low savings, so I will come here. So this is how logically you make a feature list, and this is also a logical model. This is known as rule learning. It is learned in the top-down fashion and it works on separate and conquer. So this is all about the logical models. I will continue in the next class. Thank you.